My name is Shamshullhaq. Now I am here to uh, give a brief summary on my digital assignment one from computer organization and architecture subject. And my registration number is 18BEC0284. I am from C1 slot and my serial number is 20. Uh, the digital assignment is given by Professor Danbala, and here we go. Here, these are the questions. I'll come one by one. Here is the first question. By the way, my microcontroller is Intel Skylake processor. It is used it was manufactured in 2015. It is used in many PCs and PCs. It's a computer micro. It is used in it's mostly used in computers, and it's a microprocessor. And the first question is basically draw the clear diagram of the microprocessor. And the second part of the first question is give the internal diagram of the each block. And here's the basic block diagram of my microcontroller. And this is the uh, detailed diagram of microprocessor. Microprocessor. The microprocessor I selected. Here's the second question, the instruction set of the microprocessing element that I have used in my assignment. And here are the details and the types of instruction sets used in the microprocessor. The first one is data transfer instructions, arithmetic instructions, bit manipulation instructions, string instructions, program execution transfer instructions, branch loop instructions, processor control instructions, iterations, control instructions, interrupt instructions. These are the major instructions in used in the Intel Skylake processor. And here are the further divisions and the further divisions of each instruction set. Have a look. And here is the third question. Explain the microprocessing element architecture. The architecture of the the Intel Skylake microprocessor is purely based on 8086 processor, primarily a CISC design with emphasis on backward compatibility. The instruction set is not typical CISC, however, but basically an extended version of the simple 8-bit 8008 and 8080 architecture. Here is for further information, and this is a block diagram of the processor. And now we are at the fourth question: the correlate the microprocessing element architecture. Uh, Here the question is: I have to correlate the microprocessing element. I mean the processor I have selected architecture with the architecture discussed in the module one. And here is the detailed description that I have written in the DA in the document. And now we have the fifth question: elaborate the digital organization of the microprocessing element. And here these are the Skylake registers are very similar to the 8086 microprocessor, and there are three types of micro register organization for 16-bit, 32-bit, and 64-bit individually. And here is the detailed information that I have written in the document. Explain. Here we have the sixth question. Explain the type of algorithm used for the signed and unsigned calculations. There are various multiplication instructions of the Skylake processor. Let's have a look. This is the multiplication part, and here comes the addition and subtraction part. Uh, Now we are at our seventh question. Find the type of control logic unit used and correlate its performance with the type of control unit used in module 3 in the given syllabus. The central processing unit is where the calculations of the logic operations all take place. The CPU contains a finite number of storage locations or a register, a high frequency clock like a control unit, and an arithmetic logic unit. Uh, The clock synchronizes the internal output with other CPU with other components in the system. And here is the detailed information of the regarding question. It's a lot to explain, so I want to keep this video short. And this is the block diagram of the control unit that have of my microprocessor. So, sir, the professor told us to draw a diagram. I mean, to draw a diagram in the video. So there is no that it takes a lot of consumes a lot of time. So I kept the block diagram ready to show it as a proof. Check it out. So I have used the draw.io tool from the Chrome, and this is the block diagram I have drawn as an example. This is the control unit. Uh, this is the instruction pointer. It means that it takes the instruction that you have given and try to take it from the cache. Cache is basically helps us to uh, gain the information faster than doing the whole process again and again. Instead of taking the information from the memory, cache plays an important role here in the control unit. I mean in the microprocessor. And here is the detailed block diagram, so check it out to understand easily. Now we are moving further. Now we are at our eighth question. Explain the memory management system is selected is list its addressing abilities, capabilities, memory mapping, the technique followed, find the advantage of the memory design and management techniques over the concepts given in the module 4 in the syllabus. The Skylake can sustain two loads and one store of 512 bytes per cycle. User split stores that the store addresses generation upon being sent to the store edge execution unit and store the data being sent to the separate execution unit. And here is the further information regarding this question. And these are the memory parameters of the microprocessor. Have a look. This is the in-package embedded DRAM L4 latch in the microprocessor. Have a look. And we are at our ninth question. Elaborate the pipeline and parallel processing capabilities of the unit and hazard management technique. And the first we are talking about the pipelining process. Pipelining is a process of accumulating instruction from the processor through a pipeline. It allows storing and executing instructions in an orderly process. It is also known as pipelining process. And we are moving here is the information regarding this. And now we are moving on to the parallel processing that can be a system that can be pipeline can also be processed in parallel. In pipelining, independent computations are executed in an interleaved manner, while the parallel using duplicate hardware parallel processing systems are also referred to as a block processing system. The block size indicates the size number of inputs processed simultaneously. And here are the calculations. And here we go to come to the data hazards. Data hazard is any condition in which either the source or the destination operands of an instruction are not available at the time expected in the pipeline, as a result of which the hazard management technique. And there are basically three types of hazards: data hazard, structural hazard, and the control hazards. These are the detailed description given here. Just have a look. Now we are moving on to the next question. This became so lengthy. So find whether the processing level parallelism is available in the element selected. Illustrate cache coherence and protocol list for handling memory requirements. Uh, I guess there are two types of parallelisms here. First one is the instruction level parallelism, and another one is the memory level parallelism. And here are the detailed description of both parallelisms. Let's have a look. That's it. Again, uh, thank you.